This is the introduction to calculus where you're finding limits algebraically. These are pretty easy. These are the rules basically here. The limit of a constant, limit of x, limit of the sum. I'm assuming that you're going to know these before you start the video. Taking limits is pretty easy when you do it algebraically. The only question is the limit of the rules for the quotient. So these are just rules of limits. And we're going to get to the one about the quotient rule. Okay, so the first one we have, and I have 12 examples, is the limit as x approaches 1 of -3. So that's the constant rule. So that just means it's b. It's this number here. So it's -3. Okay? This is the difference rule. And basically you're just writing the limit of x approaches 3 or gets close to 3 of 2 minus the limit of x approaches 3 of 5x. And we already know the answer to this one is the constant rule. That's 2 minus. And all you do is you plug in the 3 here. So 5 times 3. So that's 2 minus 15, which equals -13. Now, if you notice, and I don't know how specific your teacher will get, but you could have just plugged this in, this equation here, and got -13. The same thing for the limit of this one. Basically, all you have to do is limit as x approaches 2 of 8x squared is to write it as 8 times 2 squared. It's your power rule, minus 4. And when you calculate that out, you get 28. The next one I have is the polynomial rule. And again, all you're doing is substituting in -1. Everywhere there's an x, put -1. I'm just going to put, okay, plus a -1 minus 4. And when you calculate that out, this yields 2. That's your answer. Okay, and this one I went ahead and rewrote with the power rule. And you're going to plug the 2 in here and just evaluate. So we're going to get 3 times 2 minus 4 squared. And that's going to equal 4. Okay, here's your the root rule. Same thing. I rewrote it using the rule. And then basically you're just substituting your x for 1, and that gives you the square root of 9, which equals 3. Now, in this case, I went ahead and used the quotient rule. The quotient rule applies when your denominator doesn't equal 0. If I plug 0 in here, the denominator doesn't equal 0. So I broke it down and used the quotient rule. And I'm going to get 0 squared minus 4 over 0 squared plus 4, which yields -1. Okay. In this case, if I plug in -1 here, and I square it, I get 1, and that yields 0. So the quotient rule does not apply. So basically what we're going to do is try to factor this. I'm going to factor out an x. Let me do this properly. I'm going to take the limit as x approaches negative 1. And I'm going to factor out an x, get an x plus 1 over x, I'm going to factor x plus 1 times x minus 1. These two cancel, so you're left with x, the limit, as x approaches negative 1 of x over x minus 1. Plug in negative 1, and you get negative 1 over negative 2, which equals 1/2. All right, let me clean that up. All right, same thing here. When I plug in a negative 3, it doesn't work. So what I'm going to do, the denominator will be 0. So I'm not going to use the quotient rule. And I'm just going to factor this as the limit of x as x approaches negative 3. I'm going to factor this. This is going to be, let's see, x minus 4, x plus 3 over x plus 3 times x minus 3. These can cancel. So now we're just taking the limit as x approaches negative 3 of x minus 4 over x minus 3. And we get, I'm going to move it over here, and we get negative 3 minus 4 over negative 3 minus 3. And that's going to give us negative 7 over negative 6, which equals 7 over 6. That's your answer. Okay? And here's one. Same thing. When I plug in the 2 here, that leaves my denominator as 0, so the quotient rule does not apply. And I'm just going to factor, use my difference of cubes, and that's going to be x minus 2 times x squared plus 2x plus 2, so it's plus 4, all over x minus 2 times x plus 2. These cancel, and I just plug in the 2, so I'm going to get 2 squared plus 2 times 2 plus 4 over 2 plus 2, and that yields 3. Here you're going to have to factor by grouping. If I plug in 1, I'm going to get 0 here, 0 here. So the quotient rule doesn't apply. I just plugged in 1 here, and I'm going to get a 0. Now we're going to factor by grouping. So the first step we're going to do is take the limit as x approaches 1, factor out x squared of the first part, and we get x minus 1 plus x minus 1. I'm going to go ahead and put the 1 in front, and I'm going to do the same thing to the bottom, factor out x cubed, and I get x minus 1 plus 2 times x minus 1, and then put these together. So I'm putting these, I know you know how to do this, I'm going to put these together. Get x squared plus 1 times x squared, x minus 1, over x cubed plus 2 times x minus 1. And should carry this down. Limit as x approaches 1. These can cancel, and then you just plug in 1. And when you plug in 1, you'll get 1 squared plus 1 over 1 cubed plus 2, and that gives you 2/3. And the last one's similar. This one, I'm going to, the quotient rule doesn't apply. So I'm going to use factor by grouping, take the limit as x approaches or gets close to negative 1, I'm going to factor out the x squared and get x plus 1, and then factor out a 3, get an x plus 1. I have a video on factor by grouping if you're having problems with factoring by grouping. Denominator is going to be x cubed, x plus 1, plus 2, x plus times x plus 1. And now we're going to group this together. And we're going to get x squared plus 3, this here, over, times x plus 1. And then we're going to get x cubed plus 2 times x plus 1. These cancel, and then you just substitute. So we're going to get negative 1 squared plus 3 over negative 1 cubed plus 2. And you figure all that out, and that yields 4. It's pretty simple. And that is all. The next video is going to be the rate of change, the average rate of change.